A man pays a good money for a gold crown at a flea market. He gets home, hangs it on a scale, and finds its weight to be 7.84 newtons. He then hangs it or drops it in a bucket of water, and then the scale reads 6.86 newtons. Is he holding a real gold, or has he just been scammed? So for us to determine if this is a pure gold or not, we have to know the density of this crown. This crown would have a density which is given by the density as the mass of the crown divided by the volume of the crown. However, the weight of this crown in air is 7.84 newtons, and also the weight of this crown in water is 6.86 newtons. However, if we know the weight of this crown in air, we can determine the mass of this crown. So the weight in air is going to be the mass of the crown times acceleration due to gravity. So with this, we can find the mass of this crown to be the weight in air divided by the acceleration due to gravity, g. So in this case, we are going to have 7.84 newtons divided by 9.8 meters per second squared. And if you divide this, you get 0.8 kilograms. So this is the mass of this crown. So next we need to determine the volume of this crown. And how do we do that? Because this crown is an irregular shaped object. So we have to use the Archimedes principle to find the volume of this crown. However, whenever you submerge an object in a fluid, it is going to experience an upward force, right? Which we call the buoyant force. And the buoyant force, we can calculate that using the formula, the weight of this crown in air minus the weight of the crown in water. So if we know the weight in air and the weight in water, we can calculate the apparent weight of this crown, which is the buoyant force. And according to Archimedes' principle, this buoyant force has to be equal to the weight of the fluid displaced. So the weight of the fluid displaced, let's call that W fluid. Weight is mass times acceleration due to gravity. So the buoyant force becomes the weight of the fluid, which becomes now as the mass of the fluid times acceleration due to gravity. We can further simplify this because the buoyant force is also equal to the density of the fluid times the volume of the fluid, and then times acceleration due to gravity, because density times volume gives us the mass of the fluid displaced, and then times acceleration due to gravity, that gives us the weight of the fluid displaced. And according to Archimedes' principle, that weight of the fluid displaced is equal to the buoyant force. So from this, we can find the volume of the crown. The volume of the crown is equal to the volume of fluid displaced, right? So in this case, we can say that the volume of fluid displaced is equal to the volume of the crown, and that is going to be the buoyant force divided by the density of the fluid times g, acceleration due to gravity. So the volume of the crown is going to be the buoyant force, which is the weight in air minus the weight in water. So the weight in air is 7.84 newtons minus the weight in water, which is 6.86 newtons, and then divided by the density of water, which is 1000 kilograms per meters cube, and then times g, which is 9.8 meters per second squared. So 7.84 newtons minus 6.86 newtons is going to be 0.98 newtons, and then divided by 1000 kilogram per meters cube times 9.8 meters per second squared. Now 0.98 goes into itself one time, and then it can go into 9.8 10 times. It's going to be 1 divided by 10,000. So the volume of the crown is going to be 1.0 times 10 to the power of minus 4 meters cubed. So this gives us the volume of the crown. And from this, we have all the information we need to calculate for the density of this crown. Since we know the mass of the crown to be 0.8 kilograms and the volume of the crown to be 1.0 times 10 to the power minus 4 meters cubed, we can calculate the density of this crown to be rho is equal to the mass over the volume. So the mass 0.8 kilograms divided by 1.0 times 10 to the power minus 4 meters cubed. So we can do 0.8 times 10 to the power 4. In this case, we have kilograms per meters cubed. But we can simplify this further. So the density is going to be 8.0 times 10 to the power minus 1 times 10 to the power 4, and then kilograms per meters cubed. Now, from the laws of indices, we have two bases of 10 that are the same. We add the powers. So minus 1 plus 4 is going to be 3. So the density is going to be 8.0 times 10 to the power 3 kilograms per meters cubed. And this is the density of the crown bought by this man from the flea market. And if we compare this density to the density given in this problem for a pure gold, then this crown is not a pure gold. This is a good application of Archimedes Principle, where it says that the buoyant force, that is the upward force that is exerted by the fluid on an object, therefore giving it an apparent weight, is always equal to the weight of the fluid displaced. And we can always use that to determine the density of an irregularly shaped object, such as this crown. I'll see you in the next one. Bye-bye.